Hi guys, so Jadu Sen again with a new video. In this video I'm going to design an industrial structure. This industrial structure is 37-meter wide between center to center of the column, and its eave height is approximately 8.7 or 9 meter. The overall height is 12 meter. The plan is something like this. There are 8 bays in X direction, and the elevation will be something like this. So it's made of tapered sections. The columns are tapered, part of the beams are tapered, and then straight beams, and on the other side is the same. So first we will develop the geometry of this structure, and then we will apply the loads. What I did, I tried to compile a report so that all the loads are defined over here, and I will use these loads to define my structure. This building is supposed to be in Miami with moderate wind and seismic loads. When I will discuss the load, then I will come back to these sections and I will apply the wind, seismic load, and its dead load and live load, etc. All these loads have been calculated over here so that a quick reference is ready and we will be using this. So let's go back to STAAD and we will develop the model first, geometry first, and then we will apply all these loads. Let's go back to STAAD, a new project. Let's name it industrial building. Space units should be meter and kilonewton. Next, okay. I don't need this one. So let us define first our one frame. Let's the first node be 0, 0, 0 as it is. And suppose the column is 9 meter high, the eave height is 9 meters. So 0, 9 and 0. The highest point of the building is 12 meter high, and the total width of the building is 37 meter. So half of 37 is 18.5. So in X direction it will be 18.5, in Y direction it will be 12. So let us see how it looks like. It will be like this, and then I can join these members. Now the total length of this beam will be definitely more than 12 meters, and we know that one section of the beams, steel beams, are coming up to the length of 12 meter. So what we will do, we will insert a node 12 meter from the upper end, so that 6.74. okay, let us insert a node. So the distance should be 6.74. Let be a little bit more, 6.75. Add a new node. Okay. So now we can see that this beam will be around 12 meter and this part of the beam will be around 6.75. What we will define now, we will define the members. The members are tapered. We assume that the members are tapered. Let us first define this member. Member properties, tapered member. Let's say at the bottom side F1 it will be 0. Let it be millimeter, it will be more easy. Let me change the units. So member properties, tapered. On the base plate side, let F1 be 350 millimeter and F2, that is the thickness of the web, let be 15 millimeter. F3 overall height on the other side, let it be 1 meter. F4, let it be 350. F5 thickness 15. F6 is 350. And F7 is 15. Let's assign. Okay, fine. So if we see this section, fine. Now I'm going to define this portion also. Here we know that this beam will be definitely more deeper than this minimum thickness over here. So let us assign first this one. Member properties, tapered. Of course, at the start, F1 will be something around 1 meter. F2 will be same as 15. F3 on the other hand, say 500. F4 350. F5 15. F6 350 and F7B 15. Assign, close. Okay, fine. Then this we can assign a straight section. Let it define like this, tapered, but instead of tapered we will define F1 500 and F3 also 500. F2 is 15. F5 is also 15. F7 is also 15. F6 is 350. F4 is also 350. So we think we have already defined everything. Assign, close. We can mirror it, select all beams, and then mirror it, mirror about YZ plane. Node number on the plane should be 3. Okay, so this is done. Let both these supports be pin support. Now we know that the width of the building is, there are basically 8 bays in this perpendicular direction. That means in Z direction there are 8 bays. So we have to generate 8 number of portals on the same Z direction at every 6 meters. And then we have to connect them. Let us define some more nodes so that we can connect them easily. Let us divide this beam into these 2 beams into 2 parts. Insert mid node. Then let us save it. We can insert a node from node number 4 to a distance of, say, 11,500. Okay. Similarly, we can insert a node from here, 11,500. No. Only 500. Okay. No. Yeah, that was correct. Insert a node of 11,500. Yeah. Okay. There, this will be there. Maybe we need one more node in the middle. So insert mid nodes. Now select all. Translational repeat in Z direction. They are 6 meters apart. Nine. Something wrong. Undo translational repeat. Select all beams. Translational repeat in Z direction. The unit is millimeter. So we have to link them. Okay. So how many bays are there? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think one more bay is done. We can delete one bay. Let us delete one bay. Okay, so 1, 2, 3, 4, 5, 6, 7, 8 bays are there, and they are connected like this. If we see, it's okay. Let us assign other members. Property. So the lateral beams, select beams parallel to Z. Okay, one more thing. We don't need this middle beam. That's why we added 2. Yeah, we can save it. Now let us select beams parallel to Z, and let us assign W, maybe we can say 8 by 40. Now there should be some lateral bracing, so let us define some lateral bracing also. Not necessarily each and every base should be braced, but certainly the end base should be braced. So our bracing will be something like this. And from here it will be like this. We don't need these members. We can delete these members. Yeah. And of course cross bracing also needed. That's it. Let us select members having missing properties. Let us assign member properties. These can be T sections made of W8 by 40. Okay, now this bracing should be copied. Let's see. So we can repeat them after 1, 2, 3 here. Yeah. So translational repeat in Z direction. So it will be 18,000 only one time. Okay. So here it is copied. Now we can copy this again for this part also. So let us repeat. Translational repeat in Z direction. It will be something around 6,000 only one time. Okay. Oh, sorry. Undo. We can copy and we can paste over here. Paste beams. Okay, that's a good reference point. Fine. So now the geometry is done. Geometry is complete. Let's have a generated view. Now select all beams and let us render this. So here is the structure. Fine. Okay, so we have noticed one thing, that all these bracings, their faces are not parallel. Let us select all these members and let us define beta angle. They should be rotated by 45 degrees. Okay, now let's have a look how they look now. Okay, still no. So what we can see, Instead of I did this beta angle, let it be 90. Okay. How they will look like now. Okay, now they are perpendicular to each other, their faces. Okay. Or select all beams, its material, they should be all steel. Okay, let me see. Property, here these are steel. Okay, these are also steel. So fine. So we have completed the geometry. Now we have to assign the loads. Let's go back to our load calculation. What we did in our dead load conditions, I considered all the purlins, etc., and the panel, the sheet panel, everything, and ultimately I end up with a dead load of the roof, which will be on the beams. It will be around 100 kilonewton per meter. So let me assign this load. Let me select first only the top portion. That means it's something around 8,700 to 500. Okay, and now we can select beams which are parallel to x-axis. Select beams which are parallel to x-axis. Oh, they are tapered. We can select easily all these beams. So okay, let's define the load. We know that the first two load cases will be seismic load, so let's start with load case number 3. It will be dead load. Add, and the member load will be let's change the units. Member load So it will be minus 1 kilonewton per meter in global y direction. Add. Let us assign to the selected beams. So here are the loads which are applied. So these are the loads, big superimposed dead load, and we can add the self weight which is assigned to the view. So this is our load case number 3. Similarly, the roof, as per the code, the load on the roof is something around 20 pounds per square foot. No problem, we can change that. So let's have units, foot, pound. Okay. New load case. This is the live load. Load case number 4. Add. So we are going to add the floor load, which is minus 20 pound per square foot, and the range will be something from in the y direction 9 meters. 9 meters how much? Something around 29 feet. So let it be from 29 feet to 45 feet. Add. Let's see. Oh, the load cannot be generated. £20 per square foot is how much? Let's delete. So let me stop this calculation over here. In the second part, what I will develop, I will recalculate the loads on these roofs, roof beams, and then we will start from the same point. Okay, thank you very much for watching for the time being. Thanks a lot.